So now we're coming to our third video on the topic of indices. In the previous two we looked at using our basic rules to deal with multiplying, dividing, using powers of powers and dealing with negative powers and negative indices. What we're now going to deal with are fractional indices where the power is a fraction, a half, 2/3, 3/5. It could be any of those. We have to be able to deal with and usually evaluate those. So, as the text says here, usually you'll be asked to evaluate in these questions, which is to give an answer as a numerical value. What we've got here is our rule. And our rule says that the letter or the base a raised to the power of the fraction m over n is this little thing here. We have a root of a, and unlike where you've previously just seen square root signs, there's the number n there. That tells you it's the nth root of a. If that number were a 2, we normally don't write a 2 there, although you can if you wish. What we then do is we take that root and we raise it further to the power of m. Okay, so the bottom number in the fraction becomes the root, and the top number in the fraction becomes the power. And we then have to be able to deal with and evaluate those. So for example, x to the power of a half. Well, what I've just wrote here is the square root of x. If I was to write that out long ways, I would be writing that, but there's a convention that we don't write a 2 for a root. We assume if there isn't a 2 there, it's a square root, so we don't need to write that. And we don't tend to write the power of 1, as we saw earlier, that the power of 1 is just the same as the number itself, so we don't need to write a power of 1. Here I have the expression y to the power of 4/3. So that's the third root, what we call the cube root of y, all raised to the power of 4. So remember, the cube root of y simply means what multiplied by itself and multiplied by itself again gives you y. That's what a cube root is. And included in the notes that I've given out to my classes and on this slide as well, we have the first, well, I suppose the first 9, if you like, square numbers, and the same for cube numbers. Absolutely, you'll need to know the square numbers off by heart for National 5. The cube numbers, it would be really useful. The ones that tend to come up most often are these ones, but knowing further on ones would be very, very useful to you. Or if you're not able to memorize these, being able to work them out really, really quickly would be useful to you. For example, if you don't know off the top of your head that the 6 cubed is 36, well, all you have to do is be able to do 36 multiplied by 6 to give you 216. Oftentimes as well, you're having to work backwards. So if, for example, I was asked to work out the cube root of 64, if that was a blind spot in my memory and I didn't know that it was 4, if I knew the cube root of 3 was 27 and the cube root of 5 was 125, I can kind of try and work backwards. There's a bit of trial and error involved in this. Okay, let's move on and look at a few examples of using this rule. So, in this first example, you are asked to evaluate 4 to the power of a half. So the first thing you're going to do is you're going to take it from a fractional power and write it here in what we call root form. So that would simply be the square root of 4. Now if you were asked to do this in a question and you left your answer as root 4, that's not correct. You've been asked to evaluate, so we have to simplify it and evaluate it as much as possible. square root of 4. I see 4 coming up as a square number there. So that means the square root is 2. So 4 to the power of a half is 2. Now we have one that will have a little bit more work involved with it. 27 to the power of 4 thirds. So again, to begin with, I am going to write 27 to the 4 thirds in root form. So I start with 27, and I start with my root sign, and it's the third root, the cube root. I place a bracket around that, and I raise that entire expression to the power of 4. What I now want to do is I want to work out what the cube root of 27 is. Well, in this table, I see that 3 cubed makes 27. So the cube root of 27 must be a 3. And we are then looking at doing 3 to the power of 4. You may or may not have memorised that, but if you haven't, you can simply take 27, multiply by 3, and that will give you our answer of 81. So 3 to the power of 4, or our answer is going to be 81. My pen stopped working for a second, which is why the recording may have jumped a little bit. So now we see a third example. We have 125 to the power of 2 thirds. So again, we get in the habit of writing this in our root form. So 125, 125, and we're going to be looking for the cube root of 125. And we're going to then take the answer and square it. Looking for the cube root of 125, so that would be 5 squared, and 5 squared is 25. Okay, let's look at one final example of a fractional index, and we're going to combine it with negative powers. I have 32 to the power of negative 3/5. So 32 to the power of negative 3/5, I'm going to write that in our index form. Now we have to deal with the negative part first. So it's going to be 1 over the 5th root of 32 squared. We have to do a little bit of work around this, and it's probably easier just to go off to the side and work out what this part is first. The 5th root of 32 squared. I haven't shown you 5th roots, I haven't shown you 4th roots here. It's one of these things that we'll have to work out for ourselves, but if we're starting to deal with bigger roots like 5th and 4th or even 6th, chances are we're probably dealing with a 2 or a 3 or a 5 or a 10, something quite easy to work with. So I'm going to imagine that because 32 is an even number, that the 5th root is probably 2. And if I just check that in my head, 2 times 2 is 8, times 2 again, so 2 cubed. So 2 times 2 is 4. 4 times 2, so 2 cubed is 8. 8 times 2, or 2 to the power of 4, is 16. And 16 times 2 is 32, so the 5th root of 32 is 2. And I realise I've wrote a 2 here in both parts where it should have been a 3. So that's 2 cubed, which is 8. So our answer here is actually 1 over 8. And at National 5, don't waste your time trying to change that into a decimal. Leave it as a fraction, and that's perfectly fine.